Welcome to Scholar Opportunity Nexus, and in today's series of video, we'll be looking at the geographical representation of vectors, specifically cardinal representation of vectors. In as much as we always say a vector is a physical quantity that has a magnitude and a specified direction, these vectors are also must also be represented. When representing these vectors, we usually use either the cardinal point of view for the representation of vectors or bearing form. We use bearing form to represent the vector. That's mainly showing the direction in which the vector is going to. So usually, let's take this once again. That's the this vector A with its magnitude and the direction. Yes, so this a vector A having a magnitude in a specified direction, and with this vector we have to show how it's represented or where the direction is specifically going to. And today we are coming to look at the cardinal representation of vectors, where we split or break down how vectors can be represented on a cardinal point. So taking the cardinal points, we have the north, the south, the west, and the east. So we are going to use the cardinal points to show the direction of the vector, to represent the vector. So so this is what we are going to use. This is the origin. We have the north, the south, the west, and the east. So let's take our first scenario and look at how that vector with its direction. My line can. The vector with its direction will be represented. So let's take the first one, north, south, west, and east. So assuming we have a vector with magnitude represented by the line, the direction going like this, 45 degrees. Okay, so with this, mainly or basically, people say this is northeast, northeast, northeast because it's between the north and the east. But specifically, this direction or this vector shows that it was going from the east to the north, east to the north, and it was um, directed, or the angle, or it was inclined at an angle of 45 degrees. So over here, the main or specific term used for this representation would be east, 45 degrees north. But assuming the angles was here, 45 degrees was here, then it would have been north, 45 degrees east. Yes, this is a specific thing given to it, or the representation, how you have to say it. This is how it's being said. But because mostly it's between the north and the east and the angles are the same, people just say northeast, northeast. But it's actually, since it's moving from east to north, then we have east, 45 degrees north. Assuming it was moving from north to east, or it's between north and east, but it's moving from here to east, to the east direction, then it would have been north, 45 degrees east. Let's look at another one. Let's presentation as this A. Another representation. north, south, west, east. Let's take another representation as this. This is vector A, and it's also 45 degrees. It's divided exactly into two parts, so both sides are 45 degrees. But since it's showing the angle here, like the direction shows that it's moving from west to north, we won't say northwest. It's not northwest. It will actually be west 45 degrees north. Assuming the angle was here, it was moving from here to here. That's 45 degrees. It would have been north 45 degrees west. So you have to get this understanding very well, that where the angle is lying on, that's where the vector is moving from in going to the other cardinal points. Like something like this. The angle is lying on the west. So meaning the vector moved from west and it's approaching the north. So we would have west 45 degrees in north. You won't just stand up in something like this and you just say northwest. No, that's not how it works in physics. You have to be very specific and direction specific. That's why a vector has a specified direction. So it was moving from the west to the north. So west 45 degrees north. Assuming the angle was lying on the north side, then it would have been north 45 degrees west. Let's take another one. Okay, so for this two, north, south, west, east. Do you mean we had something like right here, 52 degrees? So also over here, you see that the angle is lying on the south and is between south and east. So in that case, meaning, sorry, I didn't show the direction of this vector. So meaning the vector was moving from the southern part to the eastern part. It's between south and east. So we'll have south 52 degrees east. So yes. So assuming it was rather here, so over here the angle would have been 38. I don't know if it's showing. Assuming the angle was over here and it's still the vector is still between the south and east, it would have been east 38 degrees south. So you have to be very, very direction specific. You have to know where the vector is moving from and where it's going to when showing or representing vectors on a cardinal point or looking at it at the cardinal point of view. Let's also take this another one. Assuming here was 60 degrees. We have our north, we have our south, have our have our south, have our west and east. So in this case, the vector is moving from the angle that the vector is inclined to. It's inclined from it's inclined at an angle of 60 degrees. And that's it's moving from the west to the south. The angle is lying on the west side. So meaning the vector was moving from west to south and it's inclined at an angle of 60 degrees. In this case, we describe it or represent it as west, 60 degrees south. Yes, that's basically how we represent this type of vectors. And also, assuming the vector was just lying on, let's say, north, south, west, and east. So assuming the vector was just lying on one cardinal point, let's say the vector is here. It's just moving to the east, and let's say it was 90 degrees. It's all 90 degrees, 90 degrees, 90 degrees. So we just say due east. It's going due east. Assuming the vector was here, it's going to the west. Sorry, it's going to the south, and can possibly just be 90 degrees here or 90 degrees here. So that would be due south, due south. The same for the west and the same for the north. So when a vector is lying directly or lying just on a cardinal point or the cardinal path, that's either north, east, south, or west, you just assume, you just represent it as due east. Every due east or due west. So something like this, due west. And for here, have due north. We also have this thing that sometimes confuses people when, let's say, they say north 50 degrees of east. So they give you a statement like this: the vector is north 50 degrees of east. People would confuse this and draw it as this: 50 degrees. This is north, south, east, draw the arrow, west. People confuse this and draw it as this, but this is not actually what it is. If they say something is north of another part, like north of east, it means the vector was moving rather from the east to the north. So it's actually like this. Pardon me for my crooked lines. It's actually like this: 50 degrees north of south, east, and west. It's actually 50 degrees from east rather, going to the north. So always have that in mind. When we have something like south blah 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 of east, or south this of west, or even north this of west, anything, know that it's actually the vector was rather starting from the last direction that was rather given. So meaning the angle will be on east, will be lying on east and not on west, as in this case. Yes, you'll be seeing it in most of in physics formulas or physics principles, or even questions when you are solving, and it shouldn't confuse you. You should know the right thing and how to go about it when you are giving it, when you are giving something like this. And that will be it for our lesson for today. Thank you all for joining in and watching up till this point. If you've still not subscribed to our YouTube channel, I urge you to subscribe now and get notifications on our subsequent videos. Thank you.